Made easy faculty. We are now discuss the electric circuit problems. Some important concepts. There's important concepts are. Your GATE examination, there are 4 types of questions. In any subject, there are 4 types of questions. One is a memory based questions. There is a formula based. Suppose example is, what is the resonance frequency? There's a omega naught is equal to 1 by root LC. Next, just like a second is a comprehensive, that is a concept based questions. And third one is analysis based questions. And last one is thought provoking questions. So compulsory idea must comes from your mind, you get an answer only. These types of questions. Here also we are going to discuss these 4 types of questions. So one is recall, means memory based. Next is a concept based and analytical based and thought provoking questions. Okay, shall I start now? Hope all are maybe fine. So now start the questions. Number 1. Are you ready now? Problems are worthy and prove their worthy hitting back. Okay, are you ready? So the first question is now the electric circuits. This is common to electrical electronics instrumentation students. Now the first question is, a 9 volts battery with internal resistance of 0.5 ohms is connected across an infinite network as shown in figure. The reading of ideal ammeter is, it is given ideal ammeter means the internal resistance is, what is the internal resistance is? Ammeter is different and ideal current source is different. Ideal ammeter means resistance is 0 ohms. Now find out, is given this is a infinite resistances, 1 ohm, 4 ohm, 1 ohm resistances. Now give a answer for this question. So I will give the 2 minutes of time. 2 minutes. Within 2 minutes give an answer now. My voice is audible now? It's clear now? The screen is clear? Please give a reply now. Anyone? Everything is clear now. Give an answer now. Mr. Satyam, Sanjay Kumar, give answer now. This is infinite resistances. How to approach? Ashtod Yadav given answer is 1 ampere. So shall I start now? Here is up to now the circuit is 1 ohm, 4 ohm, 4 ohms are up to infinite times. That means now from this the circuit is here, from here it is repeating up to infinite times. So find out R equivalent for the up to this one. R equivalent इधर से R equivalent तक. Okay. This is R equivalent find out करना है. First is for this R equivalent. This assumption is up to infinite is, assumption is this also R equivalent or not. You remove this one. This not effect on infinite minus something is infinite. That is R equivalent here. Okay, now 1 ohm. Here 4 ohms and 4 ohms. 1 ohm, 1 ohm, 4 ohms. This total is replaced with a R equivalent. But our intention is find out the R equivalent is here. Why here is this is a here is considered R equivalent? That is not effect on R equivalent. Infinite minus something is infinite, so it is replaced by R equivalent here. You have to find out R equivalent. These two are in parallel, then series. R equivalent into 4 is equal to R equivalent into 4 by R equivalent plus 4 plus 1 plus 1. Here the 2. So R equivalent is equal to R equivalent square, direct writing, R equivalent square plus 4 R equivalent is equal to 4 R equivalent plus 2 R equivalent plus 2 for the 8. Now 4 R equivalent get cancelled. R equivalent square minus 2 R equivalent minus 8 is equal to 0. This is a quadratic equation. The R equivalent value is always positive here. Why? Because only physical resistance are connected. So from that you get a maybe R equivalent is equal to, I'm direct writing here the 4 ohms. R equivalent is 4 ohms. Now this total network is replaced with 4 ohm resistance, nine volts is 0.5 ohms is internal resistance. Here 1 ohm, here 1 ohm, 4 ohms and 4 ohms. Our intention is find out the current to this. First find out total current. 4 parallel with 4 is 2. 2 plus here is a 1 ohm and 0.5 ohms. So total R total is equal to 4 parallel with 4 plus 1 plus 1 plus 0.5. So 4.5 R total is, so I total is equal to 9 by 4.5 is equal to 2 amperes. The total current is 2 amperes. The 2 amperes. Now the current is divided equally 4. So 1 ampere is the answer. How many have given answer? 1 ampere is a Puneet Sharma is correct. Mitesh Prakashi, Sanjay Kumar Vermaji is correct. Excellent. Shall I move to second question? Okay. Any doubt in this one? Very simple. We already discussed in the class also this type of questions. Now give answer for the second question. So previous one is based on equivalent resistance for given infinite ladder circuit. Second one is based on, just check it. You have to use a nodal analysis or a mesh analysis or KCL, KVL. Find out the value of Vx for given circuit. So fast. Anyone? No one, no one. Give an answer. Come on. The time is over now. The simple. There's one more question, just like a one more question. How to approach? Up to now, no one has given an answer. Prakashi, Sanjay Kumar Verma, Astush Yadav, Satyam ji. Now look at now. How to approach here now? First you have to look for the KCL KVL. Sir, only one here. The equation is, you are writing the equation is only one variable. Then go for the KCL and KVL. Otherwise use nodal or a mesh analysis or any method. Our intention first is what you know? Find out the volt across current source. How to find the volt across current source? Only the way is apply KVL. Maybe KVL is useful for any type of circuit. Especially if you want the volt across current source, apply KVL only. If you apply KVL in this loop, first find out what is the current is for 3 ohms and volt across here. What the current is for the 4 ohms is 4Ix. First find out the value of Ix. Here Ix is flowing here now. Here 5 ampere is, so 3 ampere is coming, Ix is outgoing. What the current will flows here? 3 minus Ix or not? 3 minus Ix. This current is visible or not? Now Ix plus 5. What the current will be here? Ix plus 5. At this node, Ix plus 5, 4Ix chale gaye. Is a living. So Ix minus 4Ix, that is minus 3Ix or not? Minus 3Ix plus 5. Just apply now KVL in this loop. Why? Our intention is find out Ix values first. So first find out Ix value here. For that purpose, you have to apply KVL in this loop. Current entering the place, leaving is minus. Current entering the place, leaving is minus. Yes or no? Clear now? So 4 into 3 minus Ix plus 2 minus 3 into current is minus 3Ix plus 5 is equal to 0. It's a KVL. 12 minus 4Ix plus 9Ix minus 15 is equal to 0. 12 minus 15, there's a 3 is equal to here 5Ix. Ix is equal to 3 by 5. Once you get a Ix equal to 3 by 5, apply KVL in this loop. You get an answer now. 4Ix value is how much? 4 into Ix. 4 into 3 by 5. This current is flowing to this one. 4 ohm resistance. So 3, you write a KVL here. 3 into minus 3ix plus 5 in place of ix, substitute 3 by 5 and plus 5 plus minus vx minus 4 into 4 ix 4 into 3 by 5 is equal to 0. Can solve. You get a vx value is 0. In a competitive examinations, the time is most important. So any method is use कर सकते, but the which one is gives the least time. So here is only you're using KCL, KVL and Ohm's law. KCL use किए थे पहले. First is, next is the KVL, next is the Ohm's law, 4 into current. Okay. No one has given an answer for this question. So Vx is equal to 0. Correct or not? Check it. Any doubt? Please ask now. Any doubts? Okay, no response. Okay, here using the concept of KCL, KVL and Ohm's law. Okay. Now move to third problem. The question is, in a given network, the power delivered by X element is 70 watts. This is X element. We don't know the element is. Which of the following can be the value of current source Ix? 14 amperes, 2 amperes, 5 amperes, can't determine. Simple question, very simple question, logical question. Give answer now. Copied. No response. Copied or not? Come on, anyone? Give answer now. My voice is audible? No response from the students means any problem is there. So now look here now, very simple here now. Is given network, the power delivered by X element is 70 watts. Here 70 watts. This 70 watts delivering is 70 watts. From given information, 8 ampere is incoming to this, 6 amperes are incoming. 8 plus 6 is how much? This current is 14 amperes. 70 watts is the delivering. So the current direction, voltage direction must be in a same, minus plus. How much voltage will be? 14 into 5. The volt across X element is 5 volts. This is over. From given information, you get a current and voltage across the X element. But our intention is find out the value of Ix. For finding the Ix, apply KCL at this node. 8 ampere is outgoing current. We don't know this current. I current we don't know. I3. How to find I3 current? If apply KCL here, we don't know this current. This is also unknown. If apply suppose nodal analysis, if it is 0, this is 4 volts, here 3 volts minus, this voltage is 1 volt, no doubt. This node voltage is 1 volt. If apply mesh analysis, here Ix is unknown. So these two currents are unknown. Two currents are unknown. If you apply here also, you know, this current is 14 amperes. But this is also an unknown current. You take any node, any equation, there are two unknowns are there. That's why you are not able to find out the Ix. You can't get a Ix value. So maybe in options none of the above दे सकते. If you are ABCD में can't determine in this case. If you know this current, then get an answer. If you know this current, get an answer. So these two currents are unknown. That's why you're not able to find out the Ix. So the answer is can't determined. Okay. Is it clear now? No response from the students. The my voice is audible or not? The screen is visible or not? Please give a response. Shall I move to next question? I'm moving to next question. In a given network, the value of Ix, where is Ix? Is the current to the 10 ohm resistance. Here 10 volts, 10 ohms, 5 ohms, 5 ohms, 5I, 10 ohms. Find out Ix value. So I will give you 2 minutes time. Please give answer now. Any that is a right or wrong, you have to give an answer now. First attempt. The question is important. Deepak ji, question is not visible. This question is. Shall I write here? Just check it your connection, internet connection. Come on. How to approach is the most important. First you have to check, is it able to write the equation in one variable? Then go for the KCL, KVL and Ohm's law. If you are not able to write the equation in one variable, then use nodal, mesh, source transformation or reduction technique. Reduction technique is only applicable, the circuit consists of one source. So now, if you are suppose not able to write the equation in one variable, in terms of one variable, then use nodal or a mesh. This is also most important. Nodal will give you the most from the given network. Choose either nodal or a mesh based on the number of equations. Here, if you are write the equation, suppose KCL, KVL से हो सकता नहीं हो सकता देखेंगे. Here dependent source phi I is there. How to find Ix? Apply KCL here. We don't know the current of the 5 ohm resistance. We don't know this current I value. Two are unknowns. If you write the KCL equation here, we don't know this current, we don't know this currents. So 3 are unknowns. So you are not able to write the equation in one variable. Then go for the either nodal or a mesh analysis. If you take a nodal mesh analysis, how many number of loops? 1, 2 and 3. 3 equations are required. Is a nodal analysis, how many number of nodes are there? First identify number of principal nodes. Here is this is a node. This is a node. It's a node. It's a node. 1, 2, 3, 4. In these 4 nodes, you would select a reference node. Very good, very good. Deepak, Jatwa, Ji, Gautam Kumar, Sripriya, Akash. Very good. Given a good response. The correct answer is correct. Here phi I, where you choose the reference node, number of equations must be minimum hona chahiye. So that purpose I am selecting a reference node is here 0 volts. So what I know, this node voltage directly, any ideal voltage source located between reference and non-reference node, that node voltage is the corresponding node voltage, phi I directly. So number of nodal equations are now here V1 and V2. That is enough. Only 2 equations for nodal. For 3 equations for mesh analysis. That's why here preference is given to the nodal analysis. I am writing here equation V1. So outgoing, outgoing and outgoing. So Ix is outgoing, that is a V1 minus 10 by V1 minus 0 by 10. V1 by 10 Ix value, V1 minus phi I upon 5 ohms, here 5 ohms, V1 minus, directly I लिखता हूँ directly, I is outgoing is equal to 0. Correct? KCL equation. Simplified. Here is a V1. LCM is a 10. 2V1 minus 10I. Here 10I is equal to 0. 10I get cancel. Check it. 3V1 is equal to 0. V1 is equal to क्या हो गया? 0 volts. So what the current is? Ix is equal to 0 minus 0 by 10. The current is 0 amperes. So 0 ampere is the correct answer for this. Is clear now? So many of Sanjay Kumar Verma is given a correct answer. Deepak, Saurav Pandey. Okay, very good. Very good. So move to next question. In a given network, the power delivered by 12 volts voltage source is dash watts. Here 12 volts, this is here 4 ohms, 6 ohms, 6 ohms, 6 ohms, 12 ohms, 12 ohms, 2 amperes. Now give answer now fast. Anyone? There are two sources are in the network. You are not able to find the power using your KCL KVL Ohm's law in this case. Next to go for the nodal or a mesh analysis or any theorems also. Find out the current through the 12 volt source. P is equal to V into I. Anyone? 11 watts. Udi 11 watts. Akash Daksh 0 watts. Shankar 0 watts. Okay, देखेंगे now. How to approach here now? Suppose if you are using a nodal analysis, how many number of nodes are there? This is suppose select as a reference node V1, V2, V3. So 3 equations. It will take a more and more time. So first you have to convert suppose this delta to star. Then minimize it into a 2 equations. You are using a mesh analysis. In this case you are using a delta to star, source transformation and mesh analysis. These 3 concepts are using in this problem. Now the 6 ohms, 6 ohms, 6 ohms equivalent in a star is 2 ohms or not? Delta to star. So here 6 by 3, 2 ohms, 2 ohms and 2 ohms. This is replaced with a now voltage source in series with resistance that can reduce the one equation. Now modified diagram is 12 volts, 4 ohms, the 2 ohms is here 2 ohms, here 2 ohms. Now this total is replaced with a voltage source in series with voltage source value is 2 into 12 is 24 volts. Here 12 ohms, here 2 ohms. Now this is 12 ohms. Only 2 equations are required. This is I1 and I2. Directly use inspection method. Twelve 4 plus 2 plus 2 plus 12. How much the value is? 6 plus 2, 8. 8 plus 2 and 2, 20 I1. Inspection method 20 I1. Both are clockwise. That is between the loop 1 and loop 2, 2 and 12. That is a minus 14 I2 is equal to sum of the voltage source in a loop. 12 volts in the direction of current, so positive, but 24 volts is opposite to the voltage direction is opposite to the current direction, so minus. So 12 minus 24, equation 1 directly. Second one is sum of the resistances are 12 plus 2, 14 plus 2, 16 plus 12, 28 plus 28 I2. Between the 2 and 1 is same, minus 14 I1 is equal to sum of the voltage sources are 24 plus. Why? Because the current and voltage are same. So 24. Solve these two. You get a I1 is equal to 0 amperes. Again 0. The current flowing to the 12 volt source is 0 amperes. So power is 0 watts. How many have given answers? $33.9 is not a correct. Yes. Okay. So let's move to next question. This is here is using delta to star source transformation. Next is mesh analysis. These three concepts are used in this case. Now, so copy the problem and give an answer. No options also given. In the network shown in the figure, the switch S is closed at t is equal to 0. Which of the following sets of results is correct? Okay, give answer within 2 minutes of time. 2 minutes, just 2 minutes. Come on. This is based on transient and steady state response. This is a problem based on initial and final conditions. DIL2. IL2 means this IL2. Oh, IL2 is not mentioned now. Please, here is. Let it IL2. This is IL2. IL2. This is IL2. Means IL1 already given, means IL2 this is. Here DIL2 0 plus by dt, dVC1 of 0 plus by dt, IL1 of infinite, VC2 of infinite. D. Purushottam Kumar A. Mukherjee given a B option. D. Akash. Sanjay Kumar Verma D. Punish Sharma A. Parmesh Bunny is option A. Right, देखेंगे now. Now start. Shall I start now? The first is before switching. So whenever attempt the transient and steady state response problem, first you have to check the circuit is connected to the independent source or not. Why? Because inductor doesn't allow the sudden change of current and the capacitor doesn't allow the sudden change of voltage for all practical inputs. So first t is equal to 0 minus, this is L1 is without source, L2 is without source, C1 is without source, C2 is without source. That means initially relaxed. So directly you can write IL1 of, लिख सकते हैं directly, t is equal to 0 minus IL1 of 0 minus is 0, IL2 of 0 minus is 0, VC1 of 0 minus is 0 volts, VC2 of 0 minus is 0 volts directly. Why? Because these are not connected to the any independent source. So t is equal to 0 plus you draw the diagram. Why? Because our requirement is dIL2 by dt. How to get a dIL2? From, if you know the volt across inductor, VL is equal to L into di by dt. From that you get a dIL2 by dt. How to get a dVc? That is from the current. If you know the current to the capacitor, that is IC. IC is equal to C dV by dt. From that you get a dVct by dt now. So now draw the circuit diagram at t is equal to 0 plus. Now t is equal to 0 plus diagram is t is equal to 0 plus IL of 0 plus value is 0. That is inductor is at t is equal to 0 plus, it acts as an open circuit. So 100 volts. Here the switch is closed. Inductor is replaced by open circuit. Why? Because IL1 of 0 plus also a 0. So 10 ohms. Here 10 ohms. Capacitor is replaced by short circuit. Here is capacitor is replaced by short circuit. Here 5 ohms is here. 5 ohms is here. And inductor is replaced by open circuit. So our intention is find out dIL2 0 plus by dt means you have to find out VL2. That is here VL2 of 0 plus find out. So these are 10 ohms. Here are 10 ohms. Here 5 ohms. Here 5 ohms. How the current is flowing now? The current is flowing through the, this is the path. No current is through the 5 ohm resistance. So the current I is equal to how much? IC. This also IC1. IC1 is equal to 100 upon 10 plus 10 plus 5. How much this value is? 4 amperes. 25. 100 by 25. 4 amperes is flowing. Here the plus minus 40. 40 volts drop. Now apply KVL in this loop. You get a VL2 of 0 plus. Why you are finding VL2 of 0 plus? Our requirement is dIL2 of 0 plus by dt. That's why you are writing now your KVL equation. So VL2 minus 2 plus plus 2 minus is your VL2 of 0 plus is equal to directly 40 volts. So what a VL2 is? L into di by dt. L into L2 into dIL2 of 0 plus by dt is equal to 40. So dIL2 of 0 plus by dt is equal to 40 by 5. L2 is equal to how much? Value is 5. 40 by 5 is 8 ampere per second. DL2 आ गया. Next is dVc2 by dt. dVc1 of 0 plus by dt. How to dVc1 by dt? Simply IC1 we know. IC1 of 0 plus is equal to how much? This value is 4 ampere. 4 amperes or not? 4. So C dVc of 0 plus by dt is equal to 4. But C value is how much? C value is here 2 farads. 4 by 2. Here 4 by 2 dVc1 of 0 plus by dt is equal to 4 by 2 is 2 volts per second. dVc1 by dt आ गया. Next is find IL1 of infinite and Vc2 of infinite directly in this diagram. So a T tends to infinite, inductor is connected to the source and capacitor is connected to the source, means it reaches the steady state. Capacitor acts as a open circuit, inductor acts as a short circuit. Just replace now with the short circuit here now. Here is the open circuit. Here is short circuit. Here is the open circuit. So find out IL1 of infinite. How the current is flowing here now? The current is flowing. Here no current will flow. 0 amperes. Why? Because here open circuited. The current is flowing in this inductor. Here 10 ohms and inductor short circuited. 5 ohms and 5 ohms. This is the current path. So IL1 of infinite is equal to 100 upon here 10 5 plus 5. 10 by 100 by 20 or not is equal to 5 amperes. This current is 5 amperes. Next is Vc2 of infinite. Here what is the voltage across here? Open circuit voltage, how to find out? Apply KVL. Just apply KVL in this loop or in this loop. Any loop. 100 minus Vc2 minus 5 into current is 5. So Vc2 of infinite is equal to 100 minus 20 or not? 25 or 20? 5 now? 5 5 are 25. So 75 volts. Which is the option is dIL2 by dt is 8 amperes. Check it. 8 ampere per second. Yes. These are 2. So which one is the option is 82575. B is the option is correct. B is correct. B option is correct. How many of you given answer B option? Okay, very good. Kirti, Das, Prayash, Payas Kumari, Sri Priya, Ankit Das, given a B. Ajay Mahab was also given a B option. Okay. Right. Shall I move to next question? This is totally based on initial and final conditions. Now give answer for this. In a figure, R may be considered infinite while 0 less than Vc less than 3 volts. When Vc is equal to 3 volts, R becomes 0. Instantly discharging the capacitor and immediately becomes infinite again. The frequency of oscillations is in kilohertz. In the circuit mein, capacitor is reaches the 3 volts, it becomes 0. Whenever less than 3 volts, it becomes infinite. So then charging, discharging is there, capacitor. So what is the frequency of oscillations? Please give answer now fast. Come on, anyone? The first question is clear or not? Most of the students एग्जामिनेशन में पूरा क्वेश्चन को नहीं पढ़ते, डायरेक्ट अटेम्प्ट करते. सो पहले यू हैव टू रीड द क्वेश्चन केयरफुली, देन स्टार्ट योर सॉल्यूशन. आप पढ़ के सॉल्यूशन स्टार्ट नहीं करना है. एनीवन प्लीज गिव आंसर नाउ फास्ट. वन. राम त्रिपाठी 0, शुभम कौशल 1, संजय कुमार वर्मा 1, पुनीत शर्मा 1443 hertz. $1.4 kilohertz. Come on. और रेस्पॉन्स होना है फास्ट. राइट और रॉन्ग फर्स्ट अटेम्प्ट तो करना है. रोबिन अग्रवाल 1.5, चार्ल्स थेविनिन 1. ओह क्या नाम है बाबा, चार्ल्स थेविनिन. अनुप्रसाद 1.4, रेड्डी 1.4, 0 hertz. अभय प्रजापति. Okay, now just like this neon lamp, how to design a R circuit for on and off of neon lamp. Okay, देखेंगे अभी. Right. First look here now. Suppose R is not there. R is equal to suppose infinite. The capacitor is charging just like a RC circuit. When our capacitor is charging, the initial charge on the capacitor is 0 volts. The final value is how much? Here final value क्या हो सकता है? While capacitor is charging, the R value is infinite or not? No current is for the resistance. So VC of 0 plus A 0 volts. VC of infinite is equal, directly I am writing now. VC of infinite is equal to how much? This is open circuited. Open circuit voltage is directly 6 volts or not? Here 6 volts. Simply R circuit. Your uses first order circuit. The VC of t is equal to final value plus initial value minus final value into e power minus t by tau. This is a formula. Now substitute what a tau is equal to R into C, RC. So VC of t is equal to infinite is 6 plus 0 minus 6 e power minus t by tau. RC is 10k into 0.1, 10k into 0.1 micro. Now VC of t is equal to 6 into 1 minus e power. After simplification you get a minus 1000 t. When it reaches the 3 volts, at what time the capacitor voltage reaches the 3 volts? At what time now? Here is here 3 is equal to 6 into 1 minus e power minus 1000 t. समझ में आया ना? Whenever it is reaches the 3 volts, then it immediately discharges to the resistance. Resistance value is 0 ohms. At what time t is equal to, ikkate I think t is equal to after simplification ikkate 0.693 milliseconds, correct? 0.693 milliseconds. If you want suppose the waveform, just here look here now. What happened here now? When a capacitor is exponentially charged, when it reaches the 3 volts, it instantly discharges. R is equal to 0. Again same, discharges, same. How much this time period is? How much this time is? 0.693 milliseconds. So how much time will take to charge 3 volts? The time is 0.693 milliseconds. So this is repeating now. Time period is pata hai. How to find frequency? F is equal to 1 by time period or not? So 1 by t time period. 1 by t is 1 by 0.693 milliseconds. This value is F is equal to 1.44 kilohertz. This is the correct answer. Okay. Is it clear or not? Yes or no? Okay. Now, right. Sorry, here is something. Right. So in this question, the current I in the middle wire reaches its maximum magnitude, that is I max, at time t. Which of the following statements are true? This is a type of question, is MSQ, multiple select question. Option A is maybe correct. Both are option A and B, or ABC or ABCD. Okay. So multiple select question है. इसमें is given this RL, this is R2L, this short circuit. Here T is equal to 0, switch is closing. These are given a options. Here is a C. Yeah, just this is a print mistake. Here is a C. A, B, C, D. Here is a C. Okay, now give answer now fast. Now audible, I think. Come on, give answer now fast. Sanjay Kumar Verma is given A and C answer. A and C. I maximum is V by 2R and T is equal to L by R log 2. A and D. Devdas. A and C. Only A. Okay, now look here now how to approach. How to find I here is a T is equal to 0 means inductor is not connected to the independent source. Initial current is 0. That is the current to the IL L is equal to 0. IL 0 minus 0. IL plus 0 also 0. Same here also 2L also here no current is flowing to the inductor before switching. T is equal to 0 switch is flowing. So very simple is I is equal to this I is equal to this current is I1. Suppose this current is the current is flowing here now. Here positive terminal here. This current is flowing in this direction. I2. This current is upward. This current is downward. Short circuit path. How to find out the short circuit current? I is equal to I1 of T plus I2 of T. What is IN of T? Just series or circuit supplies DC. Directly you would use final value plus initial value minus final value into e power minus t by tau. Directly I am writing now I1 is equal to directly लिख सकते हैं ना final value is V by R or not. How to say V by R? In final means T tends to infinite, inductor acts as a short circuit. The total current is V upon R. Here same V upon R 2L is here is short circuit. So V by R into 1 minus e power minus t by tau. Tau is equal to how much? This is L by R. So R by L into T. I2 is equal to same, voltage same, only the change is here 2L. So V by R is V by R 1 minus e power minus R by into 2L into T. Now I of T is equal to V by R, otherwise expand, minus V by R e power minus R by L into T plus means here is a plus. ये क्या हो गया? Plus means ये क्या हो गया? Here is I2 is upward ना, so in place of here plus, here is a minus. I2 is upward, I is downwards. I is equal to I1 minus I2. So this is a minus I2. So now minus I2. I2 is, you know the expression, what I2 expression is minus this I2 expression. So minus of V by R is V by R minus into minus is that is minus e power V by R into e power R by 2L into T. Bas. This is a total expression of I of t. In this V by R get cancelled. The question is क्या है, at what time t the current to the branch is maximum. Maximum current के लिए क्या कर सकते हैं, just use differentiation with respect to the time is equal to 0, di by dt 0. So 0 is equal to d by dt is minus V by R is a common, is going to 0. Just solve here now, e power minus R by L into T into here minus into minus is plus R by L. Same here is already plus is there, here minus, you're getting a e power minus R by 2L into T into my R by 2L is equal to 0, and you get a now from this t is equal to, after simplification you get a t is equal to 2 into L by R log 2. At this time the current through the short circuit branch is maximum. Differentiate, simplify it, you get a this. So what is the maximum value? How to get a maximum value? Just substitute in this. Substitute karo. I of t is equal to, in this minus V by R e power minus R by L into T. A T को substitute करना है, just substitute this T. Same similar, minus into minus is a plus V by R into e power minus R by 2L into T. T place में a substitute करो. Then get a answer is I maximum value is V by 4R. Most of the members are given A and C values, but A and C is not a correct. Why? Because here is a R by 2L is there. This is not a L. R by 2L is there. The answer is V by 4R, and also T is equal to 2 into L by R log 2. So answer is B and D are the answers. So any doubt in this one? Very good. Kirti is going to B and D. Ashutosh Yadav is going to B and D. Please write direct express for using total combined source at a time. Okay. Source is here two sources are there. Short circuit branch current के लिए I1 is incoming, I2 is opposite to the I, so I is equal to I1 minus I2. I1 expression directly लिख सकते हैं ना, directly final value plus initial value minus final value t power minus t by tau से directly लिखे, either be same. Then you have to add, differentiate, you get a answer t is equal to this, and substitute, you get a I maximum value is V by 4R. Okay. How is the question? Question is good. P and D Punish Sharma. Okay, very good. After completion of solution, you are giving the answers. That means here after means submission of your paper, then you are outside of your examination. आने के बाद, बाहर आने के बाद solution है तो there is a no use. इसलिए इधर भी before the solution, before I am suppose I am explaining के time के before you have to give answer. Okay, is it clear now? Steady state current is same in both loops. Yes, but the opposite direction. One is upward, is downwards. Here is steady state में okay, no problem. Steady state में, इसलिए steady state current is क्या हो गया? Steady state current is cancel हो गया ना? Steady state current तो cancel हो गया. But here is this transient term is not going to cancel. Why? Because one time constant is R by L, means L by R. Other time constant is 2L by R. That's why these two terms are present. इन टोटल एक्सप्रेशन में. स्टडी स्टेट में पक्का, स्टडी स्टेट में करंट इज 0 एम्पियर्स, नो डाउट. ओके. Shall I move to next question? Yes, no response. Please give a response now. How is the question is? Question is clear? Question समझ में आ गया ना ये? Steady state में L and C behave short circuit or open circuit. In steady state, L is short circuited for DC. Supply is DC होना चाहिए और step होना चाहिए. In steady state में inductor is short circuit, capacitor is open circuited. Okay, right. Now move to the next question. Right. Now the question is, the switch has been at position 1 for a long time and it is moved to position 2, 1 to 2 at t is equal to 0. The value of V at t is equal to 1 second. 1 second के टाइम पर the volt across resistance क्या है? R1 वैल्यू क्या दी है? 10 ohms. R2 value is 2 ohms. C value is 1 by 4. L is equal to 2. Now give answer within a 2 minutes of time. Fast. Whenever the circuit consists of RLC, always apply Laplace transform. Only for first order circuits, you have to use the formula final value plus initial value minus final value to the power minus t by tau. But here is the circuit consists of RLC, that's why to use Laplace transform technique. Okay. So in this case, first find out t is equal to 0 minus. T is equal to 0 minus. Find out the initial current through the inductor and initial volt across the capacitor. The switch is connected to the 12 volts. DC is connected to the inductor. T is equal to 0 minus. L with source. Means with source means steady state. Steady state में क्या होता है? Short circuit. Capacitor is also a with source. With source. Here is the open circuit. Find out the open circuit voltage. Now draw the here diagram. 12 volts. Short circuit. R1 value is 10 ohms. Capacitor is open circuited and R2 value is here 2 ohms. Here VC2. VC of 0 minus. IL of 0 minus. What IL of 0 minus is? IL of 0 minus is equal to 12 by 12. 10 plus 2 are in series. 12 by 12 is 1 ampere. VC of 0 minus is equal to here 1 into 2, 2 volts. The step number 1 is find out the initial values. Second step is apply Laplace transform directly. Laplace transform किधर भी apply कर सकते. For RL को, RC को, RLC को apply कर सकते directly. So now the t greater than 0. Here 24 volts. Switch is moved to 2. So 24 का क्या है here is 24 by S. Inductor is replaced by voltage source minus plus. This value is L into I naught. L value is how much? L value is 2. I naught is 1. So 2 inductor is LS. LS is 2S. And next resistance, Laplace transform resistance is resistance only. This is a 10 ohms, and capacitor A is replaced with a voltage source in series with the capacitor. Voltage source value is V naught by S. V naught is equal to how much? 2. This is a 2 by S. 1 by CS. 1 by 1 by 4. This is a 4 by S. Now R2 value is 2 ohms. Our intention is find out V here. Here is a V. Just apply nodal analysis. V of S minus 24 by S minus 2 by 2S plus 10. Here 2S plus 10 or not? 2S plus 10 plus V of S minus 2 by S upon 4 by S. This branch current V of S by 2 is equal to 0. Now simplify it. You get a V of S and do the partial fractions and find out ABC values. You get, I am directly writing here now. V of T expression is 4 minus 8e minus 3t plus 6e minus 4t for t greater than or equal to 0. This is expression for V of T after simplification. ये लाप्लेस ट्रांसफॉर्म होने के बाद इसके इनवर्स लाप्लेस ट्रांसफॉर्म फाइंड आउट करो. इट दिस इज एक्सप्रेशन. इट इज करेक्ट और नॉट, हाउ टू चेक? इनिशियल वैल्यू फाइंड आउट करो. इनिशियल वैल्यू मींस 0 सब्स्टिट्यूट t इज इक्वल 0. 4 minus 8 plus 6 क्या हो गया? 6 e power 0 is 6, 8 e power 0 is 8, 10 minus 8 2. Yes, initial value is 2. Final value B. How to find out the final value? In final value, capacitor is open circuit when 24 volts is connected. A भी check कर सकते. 24 here 10 ohms is an open circuit. You get a compulsory. These values are zeros and the volt across capacitor is 4 volts. So this expression is correct. So you have to substitute V of 1 4 minus 8 e power minus 3 plus 6 e power minus 4. So is nearly equal to 3.71 volts. Okay, this is using compulsory Laplace use करना in this case. So time domain में कर सकते हैं, but will take a more and more time. Why? Because this is a order of the circuit is second order. Here is a second order. That's why time domain में ज़्यादा time लेते हैं. इस वजह से you are using a Laplace transform technique. A case में don't use the formula final value plus initial value minus final value e power minus t by tau use ना करना है. That is only for RL and RC circuits के लिए. Okay. Right, very good. 3.78 is correct. Ram Tripathi, replace the inductor with the voltage source instead of the inductor or not? Initially charged inductor is initially energized inductor is replaced by current source in parallel with inductor. That is your apply source transformation, voltage source in series the inductor. L into I naught is the voltage source value and inductor Laplace transform is Ls ohms. Okay. Right, shall I move to next question? So this is something is lengthy now. Okay. Now give answer for this. It's a simple, excellent logic question. This is for given network. This is a given network is here now. This network a partial phasor diagram I shown in the figure. If L is equal to C, this L and C values are both are same, then the minimum value of R1 plus R2. R1 plus R2 का minimum value क्या हो सकता है? This is the voltage is a reference one, IR2C is the leading and IR1L is the lagging. IR1L is the current to this branch and this is a current through second branch is IR2C. Give an answer within 2 minutes of time. Fast. Give answer now fast. How to approach? L is equal to C dA R1 plus R2 from phasor diagram. IR2C IR1 L dA R1 plus R2 में पहले सपोज R2 in terms of R में लिखने के बाद if you do the differentiation from that also get an answer now. So what is the IR2C's from this diagram? How much leading here? 60 degrees from here means total is 90 degrees or not? So this is 30 degrees or not? 30 degrees. This of 45 degrees is lagging by the RL circuit. How to find this 30 degrees? Tan 30, what is the angle of RC circuit is pi is equal to tan inverse of XC by R or not? I'm not writing a minus. Why? Because already leading is there. The leading is based on here. If it's a pi is minus, Z is a minus angle, I is equal to V by Z. Pi is going to the numerator, so plus pi. So tan pi is equal to tan pi is XC by R. How much here? Tan 30 is equal to XC by R2. This is R2 or not? R2. Tan 30 is 1 by root 3. So 1 by root 3 is equal to XC by R2. So R2 is equal to क्या है? R2 is equal to root 3 XC from this. From this, you get an expression is R2 is equal to root 3 XC. Same way, here is lagging by 45 degrees. What the angle is here now? Pi is equal to tan pi. Direct लिखता हूँ. Tan pi is equal to XL by R1. Yes. Now tan 45 is equal to XL by R1. Tan 45 is 1. XL is equal to R1. R1 is equal to XL. Second expression. Relation होना चाहिए R1 plus R2. So R2 is equal to root 3 XC. If you are multiply these two R1 and R2, then get the value is in terms of L and C. Is given information LC में होना चाहिए. L is equal to C. Now I'm just multiplying R1 and R2. R1 into R2 is equal to root 3 XC. X is equal to 1 by omega C. XL. R2 is root 3 XC. Omega C. XL is omega L. Omega omega get cancelled. What is L by C value is? L is equal to C means L by C value is how much? L by C value is 1 or not. So L by C is 1. So R1 R2 is equal to आ गया root 3. From this, what R2 is equal to? R2 is equal to root 3 by R1. Root 3 by R1 आ गया. Now R1 plus R2, our intention is minimum value होना चाहिए. R1 plus R2 is equal to क्या लिख सकते हैं? R1 plus R2 is R1 plus R2 is root 3 by R1. This expression must be here R1 square plus root 3 by R1. A expression क्या करना है अभी? Minimum means you differentiate with respect to the R1. With respect to the R1, here R1 U by V rule. R1 into here is 2 R1 U by V into U dash minus U dash U into R1 is 1. So from this you get a R1 value is R1 is equal to, you get a 3 to the power of 1 by 4. R1 is आ गया 3 to the power of 1 by 4. Now R2 value is root 3 upon 3 to the power of 1 by 4. Now add these to R1 plus R2, that will give the minimum. So R1 plus R2 is equal to, I think this is a 2.63. is a minimum value. Is it clear now? So पहले क्या किए थे यार, R1 एक्सप्रेशन R2 एक्सप्रेशन को मल्टीप्लाई किए थे, इसमें से यूर यूज द L by C वैल्यू इज 1, देन R1 प्लस R2 इज इक्वल टू इन टर्म्स ऑफ R1 में लिखे डिफरेंशिएट करो, यू गेट R1 वैल्यू एंड R2 इज इन टर्म्स ऑफ R1 सब्स्टिट्यूट, then get a 2.63. How many of you given 2.62? Very good. Ram Tripathi is given an answer. Utkar Sinha also given a correct answer. Only 2, 3, 4, 5 members also given. Very good. Very good. Good response. Okay, shall I move to next question? Fast. Now. The question is, a voltage V of t is equal to 400 root 2 sin omega t plus theta 1 plus 180 root 2 sin 3 omega t plus theta 2 is applied to a series RLC circuit having R is equal to 60 ohms. R value दिए. At the frequency of third harmonic, this is a fundamental, this is a third harmonic. The reactance of L and C have equal magnitudes and the ratio L by C is 900 ohms square. The RMS current in the circuit is, give answer within 2 minutes के time. How to approach? Here are two different frequencies are there. Always use superposition theorem. At third harmonic, XL is equal to XC. What a condition for XL is equal to XC? There is a condition for resonance is XL is equal to XC. The circuit becomes a resistive in nature. That information is given. And L by C also given a 900 ohm square. Find the current in the circuit, RMS current. Two different frequencies के time पर how to find out the current, that is I is equal to I RMS square of 1 plus another I RMS square under root. So a supply voltage 400 root 2 sin omega t plus theta 1 के time पर what is the I1 and at this time what is the current, and both RMS value find out करो, then I RMS square plus another I RMS square under root करो, you get a answer. Two different frequency के time पर how to find RMS value, ये formula आपको पता है. So पहले using is given information, XL3 is equal to XC3 third harmonic, omega is equal to 3 omega. So 3 omega means here the XL3 means 3 omega L is equal to 1 by 3 omega C. So from this omega square LC is equal to 1 by 9, correct? Is L by C is equal to 900 is given. L by C is equal to 900. L is equal to 900 into C. Substitute here now, omega square L value is 900 into C, C square is equal to 1 by 9. Omega square C square is equal to 1 by 81, 900 into 9. इसका ओमेगा सी वैल्यू फाइंड करो. ओमेगा सी इज इक्वल टू 1 by 900 into 9 under root square is x is equal to 1 by omega c. Reverse karo, here xc value is from this 1 by omega c or not, 1 by omega c karo, ikate 9 3 and 330, so this is 90 ohms. xc value आ गया 90 ohms from this information. So next XL value you have to find out. How to find out XL value from this? Here 3 omega L is equal to 3 omega C. Here 3 omega L is equal to 1 by omega C is XC. XC is 90 by 3. Why 90? 1 by omega C is XC. XC value is 90. 90 by 3. So omega L value is how much? Is 3 to the 9, 10 ohms. So XL value is 10 ohms. XL value is 10 ohms, not a 3 XL value. Both are equal whenever omega is equal to 3 omega. When XL is equal to X3, XL is 3 is equal to XT3, both are equal means what is the impedance of the circuit is just Z is equal to R or not. So in this case you have to find out now I3 is equal to, suppose third harmonic current is, third harmonic current I3 RMS value use करता हूँ directly. 180 root 2 is the maximum value, directly the 180 RMS value by only resistance. Why? Because these two are going to be cancelled at omega is equal to 3 omega. So the resistance value is 60. This is 3 amperes. The resonance के time पर. But you have to find out the supply voltage 400 root 2 sin omega t के time पर what is the current through the circuit is. How to find out? Normally use I is equal to V by Z. I1 is equal to V by Z. What a V by Z is equal to V is 400. Is that not 400 or not? I am writing directly RMS value. 400 RMS value directly. Z is equal to how much? Z is R square plus XL minus XC whole square under root. Thus, so I1 is equal to RMS this value 400 by 60 square plus 10 minus 90 XL value XC value. So 60 square plus 80 square 100 4 amperes. I1 आ गया 4 amperes at omega values. I3 आ गया third harmonic के time पर 3 amperes. Total RMS current is equal to I RMS is equal to different frequency के time पर 4 square plus 3 square under root is equal to current is 5 amperes. आ गया 5 amperes. Yes, 5 amperes correct. Ram Tripathi. Options ये, yes, options ये ना, option is क्या है? 5 amperes. B is the option. Okay, clear? Option B is correct. Now move to the next question. The time instant at which Vx crosses 0 first time after t is equal to 0 in the circuit in figure. The time t in seconds is, so Vx value 0 होता है t greater than 0 होने के बाद at what time t is equal to 0, at what time t the Vx value is 0 is given 10 volts 5 sin 2t 12 volts. So first circuit देखने के बाद आपको आइडिया आना चाहिए. So whenever different frequencies are operating on the network, always only one method, only one procedure, only one theorem is applicable, that is superposition theorem. So how to approach here now? So find out Vx value for due to the 10 volts is active, suppose 5 sin 2t and 12 volts. It equal to 0 karo, then get answer. So fast now, give answer now fast. No, Mr. Puneet Sharma, 4 plus 3 is equal to 7 in a previous question में different frequency time पर how to find out the IRMS values. So frequency omega is equal to omega, that is a 4 amperes, omega is equal to 3 omega 3 amperes. Two different frequency के time पर how to find out RMS value is IR1 square plus IR2 square under root. Give answer now fast. Come on. $19.34 seconds. How to approach different frequencies are operating on the network, always use superposition theorem. Either than those, suppose we are using a superposition theorem. Now 10 volts is active, this is short circuited, this is short circuited. Once it's short circuited, no current is flowing through the 3 kilo ohms and 5 kilo ohms. Here the node voltage is क्या हो सकता है 0 volts. Here the voltage क्या हो सकता है, just use a voltage division rule. So here Vx dash लिखता हूँ, Vx dash is equal to 10 volts is active के टाइम पर 10 into here 2k by 3 plus 8k plus 2k 10k. So value is how much? 2 volts. 10 volts is active. Next is 5 sin 2t is active, suppose. This is short circuited. Here no current is flowing. Here 0 volts only. 5 sin 2t 2 kilo ohms 8 kilo ohms. The volt across 8 kilo ohms is the direct Vx value. Vx is nothing but this node voltage minus this node voltage. This node voltage क्या हो गया 0 हो गया. So now Vx double dash is equal to here 5 sin 2t into again use a now volt across 8 kilo ohms find out करो 8k by 8k plus 2k. So 10 5 1s are 5 2s are 2 4. So आ गया 4 sin 2t. Vx triple dash. So the time here is short circuited, here is short circuited, only this is active. So no current is flowing here now, 0 amperes, here 0 amperes. So Vx is here the current is flowing, the volt across here. If the voltage find out karo, what the voltage will be here 12 into 3k upon 3k plus 5k. 36 by 8. Here 4 3s are 4 2s are. So 4.5 or 2.5. Here 4 2s are 8, 4 3s are. So 3 3s are 9, 9 by 2 is 4.5. But here is, check करो, here is 0 ohms. So minus is here now. Minus plus 0 minus this value. This value क्या है? 4.5 here is. So 0 minus 4.5. This value is लिखना है minus 4.5. So total Vx is equal to, लिखना है total Vx is equal to, first one is 2 plus 4 sin 2t and minus 4.5. Simply Vx equal क्या करना है? 0 करो. Here is a minus 2.5 plus 4 sin 2t. From this you have to find out t value is some 337 point something milliseconds. Check it. Okay, how many have given answers? 0.26. No, 337.56 milliseconds. Most of the members are doing mistake here now. थी होने के बाद आपको यू गेट ए डिग्रीज में आते हैं. डिग्रीज को क्या करना है? कन्वर्ट इनटू ए रेडियंस. कन्वर्ट रेडियंस में कन्वर्ट करना है. देन ओनली गेट ए टी इज इक्वल 337.56 मिलीसेकंड्स. सो ये याद रखना है. सो व्हेनेवर साइन इनवर्स ऑफ समथिंग योर कैलसी विल गिव द ऑलवेज इन डिग्रीज. बाद में कन्वर्ट ए रेडियंस, देन टी यू गेट ए 337.56 milliseconds. Yes, very good. Biksa Shah is given a correct answer, and Utkar Sinha also given a correct answer. Astosh Singh also given a correct answer. Okay, so this is you are using a voltage division and superposition theorem. Now move to the next question. Give answer for this question. For the circuit shown in figure, Norton's current and Norton's equivalent impedance at terminals AB. Option A, B, C and D also given. These are 2 ohms, this is J1 ohm, 3 I1. So the circuit consists of dependent and independent sources. So how to find out the ZTH and how to find out short circuit current? Just give answer now fast within 2 minutes. Come on. No response. Come on, it's a very, very important concept here now. So Norton's current में शॉर्ट सर्किट करो. This is the current is ISC. The current of the dependent source is ISC. If you apply KCL at this node, you get a ISC value. If you apply KVL in this loop, this is a 2I1 plus 3I1 is equal to 0. So only single step is two I1 plus 3I1 is equal to 0. So I1 is equal to how much? I1 is equal to 0 हो गया. I1 is 0 amperes means this is short circuit 0 volts. ये short circuit. A भी इसमें करंट is 0 हो गया. So ये रिप्लेस करो, इसका रिप्लेस करो, रिमूव करो. ये शॉर्ट सर्किट है. ये टोटल शॉर्ट सर्किट के अक्रॉस नो करंट विल फ्लो थ्रू द J1 ohms. ये शॉर्ट सर्किट के पैरेलल में है. J1 is in parallel to the short circuit branch, इसलिए the current is 0 amperes. Here is 0 amperes. The current is 2 angle 45 directly through the short circuit branch. So ISC is equal to 2 angle 45 amperes. आ गया. Single step, only one step. Next, for finding the ZTH, there are two methods are there. One is ZTH is equal to VTH upon ISC. ISC तो आ गया. In this case, don't inactive any sources. Open circuit voltage find करो. Then get a ZTH. Another method is using V by I ratio. In this case, inactive independent sources. So I'm using this method. That is your choice. Whether use this or use this. So inactive independent source means old current source is replaced by open circuit. Open circuited. Only 2 ohms here now. This current is I1. Here is a J2. Here minus plus 3I1. Where you want the old impedance, connect the external source. Is a V. Find out this I. V by I ratio find out करना है. If you apply K, here is I is coming. You apply I is coming here now. I will be divided. Write a KVL equation in this loop. V 3I1 plus 2I1. आ गया V is equal to 5I1. Our intention is not in terms of I1. In terms of I में होना चाहिए. You have to replace I1 with I. How it is? I1 is equal. The current is coming. The current is divided. Use current division rule. I1 is equal to I into total current into opposite is J2 by 2 plus J2 or 2 plus J1. This is J1 by 2 plus J1. So partial fraction here is a restoration karo 2 minus j1 by 2 minus j1. You get I1 is equal to here 2 j1 1 here plus j2 by a square minus b square, this is 5. I1 आ गया I into this. Now v is equal to 5 into I1. 5 get cancelled. V by I ratio is directly ZTH is equal to 1 plus J2. So option क्या हो गया? 2 angle 45 and 1 plus J2. The option is क्या है? Here is C is the option. Correct? C is the correct option. How many have given us correct? C is, oh, Abai Prajapati Utkar Sinha. Very good, very good. Yes, yes, yes. Subham, Kaushal, Paramesh, Banni. Very good. Ankit Kumar. Okay, C is the option. Right? Clear now? The concept is just using a KCL and KVL only here. Just using KCL, KVL and current division rule. Now, give answer for this question. In the circuit shown in figure, V is equal to, where is the V? Here is the V. 10 volts. Where is the I? I is here, supply current, 1 ampere. And R is equal to 10 ohms. The value of Ix found to be 0.5 amperes. The corresponding value with R is equal to 20. Second case में R is equal to 20 ohms. V is equal to 20 volts. I is equal to minus 2 amperes. E is minus 2. Which one is the minus 2 here now? Minus 2 is Ix. Now क्या किया थे अभी? If R is equal to 5 ohms, not 50, 5 ohm, V is equal to 10 volts, I is equal to 2 amperes, then the value of Ix is. Fast now, give answer now. Come on. Fast, give a response now. Come on. This is a block box model. I'll give the hint also. Any linear bilateral network can be replaced by voltage source in series with resistance. So a block box में linear resistive circuit है. This total circuit is replaced with a now Thevenin voltage, Thevenin resistance. Yes or no? No one. Give an answer now. Fast. Up to this, including this source now, this is source. This just like a load जैसे act कर रहे हैं. So this total, this network, not including this resistance, is replaced with a VTH in series with RTH. Now connect R and voltage V. This is Ix. So from first information, whenever I is equal क्या है 1 ampere के टाइम पर you're considered is a VTH. ये ध्यान में रखना है, it's the most important. I is equal 1 ampere is a source current. At the time open circuit voltage is VTH. R is equal 10 ohms. ये 10 ohms है. So पहले लिखता हूं यार इस VTH is equal to Ix into RTH. KVL is plus Ix into R plus V. So VTH is equal to Ix वैल्यू सब्स्टिट्यूट करो पहले में. Ix वैल्यू क्या है 0.5 RTH plus 0.5 into 10. R is equal to how much? 10 ohms plus V is equal to how much? 10 volts. So आ गया VTH is equal to 0.5 RTH plus 15 R naught. 5 plus 10 15. इक्वेशन 1 आ गए फर्स्ट इंफॉर्मेशन से. इन सेकेंड इंफॉर्मेशन देख लो, करस्पॉन्डिंग I क्या हो गया, I is the most source current is changed to -2 amperes. 1 ampere के टाइम पर the Thevenin voltage is VTH, but the current source is changed. The open circuit voltage also changes. How much open circuit voltage now? Now open circuit voltage is 1 ampere के टाइम पर VTH, -2 ampere के टाइम पर क्या हो सकता है -2 VTH. Yes or no? 1 ampere के टाइम पर VTH, -2 ampere के टाइम पर -2 VTH. If it is +2 amperes, 2 VTH. RTH is no change in the RTH. सोर्स करंट का इफेक्ट नहीं रहते हैं, बिकॉज सोर्स करंट को क्या करते हैं ओपन सर्किट करते हैं RTH के टाइम पर, फाइंडिंग RTH के टाइम पर. सेम R here is Ix here plus R minus V. In this case -2 VTH is equal to RTH into Ix value is how much? -2. So -2 RTH R into Ix. What R value is? Check करो. R is equal to 20 ohms plus 20 into -2. 20 into -2. Current is -2. V value is how much? 20 volts. This is second equation. Solve 1 and 2. Get a VTH and RTH. Once you get a VTH and RTH, that VTH value is due to current source value 1 amperes. 1 ampere के टाइम पर that is the open circuit voltage. से लास्ट में क्या दिए I is equal 2 amperes के टाइम पर क्या हो सकता है ना, इसमें से आप कर सकते हैं सॉल्व करें तो VTH RTH आते हैं. यू कैन गेट आने के बाद after getting a VTH and RTH, now the circuit is 2 VTH. Why 2 VTH here now? Because of the current is 2 amperes. You get a RTH also. RL तो है, यार voltage source is value है from KVL equation. You get a Ix value is the 2 amperes. Just check it. मैं डायरेक्ट आंसर दिए VTH आने के बाद 2 into VTH करो, RTH value तो from this 2 equations you get a RTH value. Substitute here now. You get answer Ix is equal to 2 amperes. How many of you get the same answer? How -2 VTH? Jyoti Sinha ji. Here is VTH value दिए, VTH value is taken for I value is 1 ampere. 1 ampere के टाइम पर open circuit voltage is VTH. If you are change the source current or source voltage, corresponding open circuit voltage also changes. So if it I is equal to 2 here is a I is equal to 2 amperes, it becomes VTH is becomes 2 VTH. open circuit voltage. If I is equal to minus 2 amperes, minus 2 VTH. This is linear. लीनियर में चेंज होना चाहिए. सोर्स करंट चेंज होने के कारण ओपन सर्किट वोल्टेज भी चेंज होता है. दिस इज द मोस्ट इंपॉर्टेंट हियर नाउ. ओके, नो वन इज गिवन आंसर नाउ. ओके, right? Now give answer for this question. The network S is connected. S means source network is connected to the load network Li shown by dashed lines. The power transferred from S to L, source to load, would be maximum when R is in ohms. How much the value of R, so that the maximum power absorbed by the load. So A is 100, 200, 0, infinity. Give answer now. This is a 40 ohms. This is not a 2 ohms, it's a 40 ohms. Okay. So this is based on maximum power. Previous is Thevenin's theorem. So superposition completed, Norton's completed, Thevenin's completed. Now maximum power. Next is enter into the magnetic coupled and 2-port. Okay. No problem. We are going to discuss. Yes, magnetic coupling is there. Yes. Syllabus में है. M element means magnetic coupling. M element is mentioned in your syllabus. That is a magnetic coupling circuits. में M is mutual inductance. Yes, we are going to discuss 2 problems based on magnetic coupling. Ram Tripathi C. C is answered directly. A is answer. No. मैग्नेटिक कपलिंग के पहले भी हैं. नॉट ओनली ईयर, प्रीवियस ईयर मैग्नेटिक कपलिंग से क्वेश्चंस आए थे पहले भी. ओके नाउ, और टू अप्रोच नाउ, दिस टोटल नेटवर्क इज रिप्लेस्ड बाय VTH in series with RTH or Thevenin equivalent. I'm using a source transformation, 2 amperes 60, that is a 120 volts, in series 60 ohms. This also replaced with a now 2 amperes 40 ohms. Here minus plus, same direction. 2 into 40 is 80 volts, in series with 40 ohms. Now this VTH is how much here now? VTH क्या हो सकता है? 120 plus 8, 200 volts. So this total is 200 volts. In series 100 ohms. This is RTH and VTH. Now connect. This is R. Here 0.5 amperes. This is also replaced by source transformation, voltage source in series with 200 ohms. I'm using now. .5 200 means 100 volts, 200 ohms. 0.5 into 200 is 100 volts. The direction is downwards, 100 volts. So maximum power transformation theorem gives the 50% efficiency in a resistive network. Why? Because half of the voltage drop across source resistance वजह से 50% efficiency देते हैं. That's why here is 100 volts will be drops. Maximum power में क्या है? Half here, half is load के across. So 200 से 100 volts across the 100 ohms and remaining across the load. So here is voltage is how much? 100 volts. Now just apply KCL. This current is incoming, this current is outgoing. So 200 minus 100 by 100 is equal to 100 plus 100 upon 200 plus R. So in this case you get a R is equal to 0, but all the cases are not 0. In this case only R is equal to 0. Suppose your change the 0.5 ampere is suppose 1 ampere, then different. 0.5 के time पे suppose 0.25 है, R value will be something. But in this case only here is 1 ampere, 200 plus R is equal to 200. You get a R is equal to 0 ohms. All the case R is equal to 0 ohms नहीं होता है. If you change the 200 ohms, 100 ohms है suppose, then different. If you change the 0.5 is 0.25, then different. But in this case here is R is equal क्या आ गया? 0 ohms is the correct answer. Okay, directly R is equal to 0 ohms नहीं बोलना है directly. ये होने के बाद करना है. So maximum power transfer, if your load consists of either current source or a voltage source, you use the concept of maximum power transformation theorem gives the 50% efficiency. Why? Because half of the voltage drop across source resistance वजह से ऐसा होता है. Only this is applicable in a resistive network. रेसिस्टेंस होना है, इधर रेसिस्टेंस होना है, लोड में भी रेसिस्टेंस होना है. राइट. Right. Now two-port. A two-port resistive symmetrical circuit connected between source and an 8 ohm load gave the measurements indicated in figure. Measurements to दिए. The transmission parameter of the circuit is options also given. Transmission parameters means ABCD parameters for this network क्या है? ये measurements lab में conduct किए थे. नेटवर्क के इनसाइड ब्लॉक बॉक्स में क्या क्या एलिमेंट्स है पता नहीं है. इसका एलिमेंट्स का डायरेक्टली ये एलिमेंट्स का ट्रांसमिशन पैरामीटर्स डायरेक्टली फाइंड आउट करो बेस्ड ऑन द गिवन इंफॉर्मेशन. नाउ गिव आंसर फास्ट. If any resistance will there, then it will be definitely consume the power. Then it all cases it will be reduce efficiency. Yes, reduce efficiency. When a source resistance वजह से efficiency कम होता है, no doubt. That's why you have to maintain a source resistance is as minimum as possible. पक्का होता है. इन प्रैक्टिकल किसी पे तो होता है. Efficiency तो 100% नहीं हो सकता है. What is the option is? Fast. Ahan Basu B is the answer. 2312. R is equal to 0 is not all the cases. राम त्रिपाठी इफ यू वांट मैक्सिमम पावर के लिए आप देख सकते हैं डिफरेंट कंडीशंस आर देयर. R is equal to 0 always is not correct. In a previous case R is equal to 0, my already given the explanation. If you are changing 200 ohms to 100 ohms, R value will be different. If you are 0.5 amperes के जगह पर if you are 0.25 amperes, R value is different. You have to put 200 ohms के जगह पर 100 ohms करो, you get a different value of R. B. Answer is B. Now look here now. What a given information is here. ट्रांसमिशन पैरामीटर्स पहले इक्वेशन लिखो v1 इज इक्वल टू a v2 माइनस b i2. What is I1 is equal to? I1 is equal to CV2 minus DI2. अभी देखेंगे what the given information is here. A two-port resistive network. Resistive means all resistive networks are reciprocal networks. Directly बोल सकते हैं. So what a reciprocal condition is? AD minus BC is equal to 1. ये पक्का होता है रेसिस्टिव नेटवर्क में. पक्का रेसिस्टिव नेटवर्क रेसिप्रोकल होता है. सिमेट्रिकल नेटवर्क भी. सिमेट्री मीन्स A is equal to D. Thus using these two to find out ABCD values. So from this given information, what is this value is V1 or not? This is V1. V1 is equal to how much? V1 is equal to 19 volts. What I1 is equal to? 10 amperes. I1 is 10 amperes. Next is V2 is equal to 8 volts. What about I2 is? I2, this current is 1 ampere. 8 by 8 is 1 ampere. I2 is minus 1 or not? I2 is equal to minus 1. Now substitute these values in the equation. V1 is 19 is equal to 8A. V2 is 8A. BI2 plus I2 is 1 is a B is the equation 1. Equation 3 suppose. I1 is equal to how much? 10 is equal to 8A, CV2, C, 8C and plus D. D प्लेस में A सब्स्टिट्यूट करता हूं. 10 is equal to 8C plus A. सिमेट्री में ना. नाउ फ्रॉम दिस देख लो A इंटू A. D प्लेस में A सब्स्टिट्यूट करता हूं. A स्क्वायर माइनस BC is equal to 1. So now what a B is equal here now? If it is a B is equal to A square minus 1 by C. A square minus 1 by C. Substitute here now. Whenever B place में A square minus 1 by C substitute करो. 19 is equal to 8A plus A square minus 1 by C. So here 8C is equal क्या लिख सकते हैं? 10 minus A लिख सकते हैं ना. So you have to multiply and divide with 8 किसे करो directly. 8C place में क्या करो? 10 minus A substitute करो. You get a value. A value get A value is equal to after simplification 2. A and D both are same. D also 2. So what option is? ये होना चाहिए. So reciprocity के so based on reciprocity आप देख सकते हैं AD minus BC 16 minus 15 1. AB reciprocity है. AB symmetry है. बट A ऑप्शन नहीं है. A ऑप्शन भी नहीं है. 9 minus 8 ऑप्शन में A रेसिप्रोकल है, सिमेट्री है, बट ऑप्शन क्या है? 2 2 है. देन सब्स्टिट्यूट C वैल्यू फाइंड आउट कर सकते हैं बेस्ड ऑन दिस. A स्क्वायर माइनस 1 by C से B एंड C इज इक्वल टू हियर 10 minus A by 8. So option is B is correct. Okay, right. Next. The network N described by the following short circuit admittances. Y11 is equal to Y2 is equal to 2 Siemens. S for Siemens, not a your inductor in a, not in a Laplace. Here 2 Siemens. Y21 is 2 Siemens and Y12 is equal to 1 Siemens. If Is is constant equal to 9 amperes, then power absorbed by 2 ohms is. How much power absorbed by 2 ohms? If the supply current is 9 amperes. Give answer now fast. Ram Tripathi is he. Every resistive network is a reciprocal network. Every resistive network is a reciprocal network. इसलिए resistive बोले तो that is always a reciprocal. So AD minus BC is equal to 1. Come on, what the answer is? The power observed by 2 ohms is anyone, come on. No one. Give an answer now, fast. Come on. From given information, शॉर्ट सर्किट पैरामीटर्स इक्वेशन लिखना है पहले. I1 is equal to y11 v1 प्लस y12 v2. I2 is equal to y21 v1 plus y22 v2. I1 is equal to, what the y11 is? Y11 is 2 v1, y12 is 1 plus v2, equation 1. I2 is equal to, y21 is also a 2 v1, y22 is also a 2 v2. Just apply now nodal here. Apply nodal analysis. IS is incoming current, that is 9 ampere is incoming. Outgoing currents are, this is a V1, this is a V2. V1 by 2 plus I1 is there. What is I1 is? Just replace I1 is I1. So V1 minus V2 by 1 by 2. Directly लिख रहा हूं. V1 minus V2 by 1 by 2 is 2 into V1 minus V2. Now substitute I1 value is here. What I1 is here? लिख लो. 9 is equal to V1 by 2 plus 2V1 plus V2 plus 2V1 minus 2V2. क्या गया यार इस 9 is equal to 2 plus 2 4.5 V1 minus V2 minus 2V2 plus V2. So equation 3 है. इधर इक्वेशन लिख लो. आउटगोइंग V2 by 1 plus I2 plus 2 into V2 minus V1 by 1 by 2. 2 into V2 minus V1 is equal to 0. No incoming currents. So V2 plus I2. Where is I2? I2 is here. 2V1 plus 2V2 2v2 plus 2v2 minus 2v1 is equal to 0. 2v1 get cancelled. v2 plus 2v2 plus 2v2 is equal to 0. v2 क्या हो गया यार, इस v2 is equal to 0 हो गया डायरेक्टली. v2 वैल्यू क्या हो गया, 0. v2 वैल्यू 0 हो गया. Now v1 value, so v1 value from this, from third equation, v1 value आ गया 9 by 4.5, that is 2 volts. Power P is equal to v square by r, v1 square by r is 2, that is 2 watts is the answer. How many of you given answer now? 2 watts. Mr. Kar Sinha given answer correct. So next is Paramesh Bunny also given answer correct. Only 2 students are given answer. Okay. Now just using a nodal analysis and equations of y parameters. A magnetically coupled circuits. In the magnetically coupled circuit shown in figure, the power consumed by 4 ohms is 16 watts. The value of coefficient of coupling K is. K coupling coefficient का formula पता है, use a formula, then give an answer now. So given information is 4 ohm is consumption power is 16 watts. Now fast. Punish Sharma ji, ground is there. N1 and N is consists of some elements. Here bottom one is the ground. V1 minus V2 by 1 by 2. Plus or minus the V1. The ground is there. Highest is equal to 9 amperes. Bottom one is the ground. Okay. First, how to approach. Our requirement is coefficient of coupling K होना चाहिए. K is equal to formula क्या है? K is equal to m by root L1 L2. But there is no L1 value पता नहीं है, L2 value is unknown, M value is unknown. So in terms of ohms में है, so ohms में बोले तो what is now here is xm by root xl1 into xl2. Just multiply and here is a divide with omega, say omega m, omega L1, omega L2. Omega L1 is XL1, omega L2 is XL2, omega M is XM. XL1 is we know, XL2 also know, but you have to find out XM value. How to find XM value? These two are connected in a parallel or not? Parallel mein hai. How to find M is negative or positive? How to find how it is? You just you to indicate the current direction. Indicate karo. Across the coil only. Indicate karo. के ऊपर indicate करो. This current is leaving from the dot. This also leaving from the dot. Both are leaving from the dot means M is positive. M is positive का अर्थ है M is always positive only. But the series aiding or opposing, the flux is aiding or opposing का information देते हैं these dots. The both currents are leaving or entering. The mutual flux is always additive to the self flux. Both are connected parallel. So whenever parallel aiding formula is L equivalent is equal to L1 L2 minus M square by L1 plus L2 minus 2M. This is a formula. But here is L equivalent, L value नहीं है, XL equivalent. ऐसा भी लिख सकते हैं. XL equivalent is equal to XL1 XL2 minus XM square upon XL1 plus XL2 minus 2XM. इसमें XL1 पता है, XL2 पता है, unknown is XM, but you have to find out XL equivalent. Then only get a XM value. How to find XL equivalent is given some information here now. The 4 ohms is consuming the 16 watts. That means I square R is equal to 16 watts. R is equal to क्या हो सकता है? Here is I value क्या हो सकता है? 16 upon R value is 4 under root. 16 by 4. 4 and I is equal to how much? 2 amperes. The current in this branch, in this circuit is 2 amperes. So find out Z value. Z is equal to V by I. V is equal to 10 upon 2. 5 ohms. This is a magnitude. This total impedance of the circuit is क्या लिख सकते हैं? Z is equal to R plus J XL equivalent. This is XL equivalent इसका. So Z value is 5. Magnitude is equal to, magnitude कैसे लिख सकते हैं? R square plus XL equivalent square under root. R value is known. From this you have to find out XL equivalent value is directly बोल सकते हैं 4 बोले तो ये 3 होता है. From this you get a XL equivalent value is 3 ohms. Now substitute in this equation. 3 is equal to XL1 3 into 5. 3 into 5 minus XM square. Unknown XM square is upon XL1 3 plus 5 minus XM 2XM. So from this you get a XM value is 3. Get a 3 values XM. Now K is equal to XM is 3 root XL1 3 into 5. So K is equal to 0.774. Coefficient of coupling is always less than 1. Always less than means K is only between 0 and 1. There is no units for coefficient of coupling. 0.774 is the correct answer. Very good. Pratik, is given answer correct. Ashutosh Yadav, Ahan Basu, Siba Prasad. Thank you. Right. इसका क्वेश्चन का आंसर दे दो. लास्ट और एक क्वेश्चन 3 पेज में करेंगे, देन क्लोज द सेशन. The question is, find the transformer ratios A and B in a circuit such that the ideal source supplies 1000 watts, half of which is delivered to 100 ohms load. A वैल्यू क्या है, B वैल्यू क्या है, बोलो फास्ट. बाबू anyone, come on. I think electrical students are perfect in a transformer. How to approach? His given information is power delivered by the ideal voltage source is 1000 watts. From that you get a current in this loop. And second information से एक current भी पता होता है. Now next find out this current, get an answer. Now only resistive elements are there. So P is equal to whatever V into I. There is no cos pi, there is no inductor, there is no capacitor here. So P is equal to P generated is equal to Vs into, suppose this is I1. This current is suppose I1. Suppose this is I2. This is I3. So what is I1 is equal to Pg already given 1000 watts. Vg is 100 into I1. Why writing only V and I? There is no cos pi because there is no inductor. There is no capacitor. So I1 is equal to 1000 by 100 is 10 amperes. I1 is 10 amperes. Hundred ohms is half of which is, so P 100 ohms is given information is 500 half. From this I3 square into 100 is equal to 500. I3 आ गया √5. I1 आ गया, I3 आएगा. नाउ फाइंड I2 कैसे फाइंड करना है? I2 के लिए ये इंफॉर्मेशन दिए ना, एनर्जी power delivered is equal to power consumption. How many elements are power consumption? 4 ohms consumption, 2500. So Pg is equal to P4 plus P25 plus P100. But the P4 is equal to I1 square into R. P4 I1 is how much? 10 square into 4 ohms. 400 or not? So P4 is equal to 400. Substitute here now. PG is 1000. P4 is 400. P25 we don't know. P100 is 500. From this you get a P25 is equal to 100. So I2 square into R is equal to 25. So I2 is equal to how much? 100 by 25 is 4. These are 2 amperes. So now we know I1 by I2. I1 by I2 is equal to N2 by N1 or not? I1 by I2 is equal to N2 is equal to A by 1. This A by 1. Substitute. I1 is 10. I2 is 2. A by 1. A is equal to आ गया 5. Same way now. I2 by I3 is equal to N2 by N1. I2 by I3 is equal to B by 1. Substitute, you get a B is equal to 0.8944. So option क्या हो सकता है यार? Option is A is the option. A is equal to 5, B is equal to 0.8944. Very good. Very good. Punish Sharma, Paramesh Banni, Astos Adhav, Ahan Basu, Mitesh Prakash, Utkar Sinha also given a correct answers. Now, very simple question. This is very simple. A balanced delta connected load draws 17.32 amperes of line current and 3 kilowatts at 400 volts. The value of resistance and reactance of each phase of the load is. Last question. This question is belongs to the three-phase circuits and is only balanced here now. Unbalanced के लिए there are 3 methods, either use nodal, mesh or elements. ये balance के लिए directly बोल सकते हैं. Total power is given 3 kilowatts. Each phase balanced है ये. Is given information is V line, V phase in a delta is same or not? Here 400 volts. I line is given 17.32. 17.32 is another 10 root 3. But I phase is in a delta connected load. I phase is equal to I line by root 3 or not? I line by root 3. This value is 10 root 3 by root 3 is equal to 10 amperes. So what a power P is equal to formula in a three phase root 3 VL IL cos pi. So 3 kilowatts 3000 into root 3 VL is 400, IL is 10 root 3. Find out cos pi. The power factor angle is always between phase voltages only, not a line voltages. From this you would get a cos pi is equal to 0.25. How to find out Z? Total Z is, total Z phase is equal to V phase by I phase or not? V phase is 400, I phase is 10, 40 ohms. So R is equal to, we know Z cos pi or not? This is a triangle R, XL and Z, this is a pi. So R is equal to 40 into 0.25, that is 10 ohms. XL is equal to, directly can write Z square minus R square under root. You get a 38.73. Okay. A is correct. Very good. So A is the correct answer. Another also possible. 3 kilowatts is arc arm is 1000 watts. Equally divided. 1000 into 3 is 3 kilowatts. ऐसा भी कर सकते. Okay. One question एक क्वेश्चन ट्राई कर सकते आप. Yes, last. A 100 volts 100 watt lamp is correctly operated from 240 volts 50 hertz supply by connecting in series with an inductor L. A capacitor C is connected across the supply to make power factor unity. The quality factor of the circuit and value of C in microfarad respectively. Anyone last question? So just to give you the hint, 100 volts 100 watt lamp is, what the resistance value is. First find out resistance value. Circuit is resistance, inductor and it is capacitor. Here 240 volts 50 hertz, 100 volts 100 watts. R is equal to V square by P. P is equal to V square by R or not? From this you get a R is equal to 100 into 100 by 100. ये आ गया 100 ohms. L value is unknown, C value is unknown. How to get a L value is, first find out XL. XL is equal to VL by I. Current पता है, how it is, 100 by 100 is 1 ampere current. Current is we know. Next find out VL. Total voltage how much? 240. So V is equal to VR square. Don't use VR plus VL. Not a scalar addition, always vector addition. VR square plus VL square. V is पता है. VR square. We know the VR. VL value find out करो. VL value. From this you get a XL value. Once you get XL value, 2 pi FL, get a L value. What is the need of L value? Find out quality factor of the circuit. What is quality factor of circuit? This circuit is nothing but practical tank circuit. A practical tank circuit का what the quality factor is XL by R. R omega naught L by R. सी वैल्यू का आउट फाइंड आउट सी वैल्यू के लिए दिए पावर फैक्टर यूनिटी करो. पावर फैक्टर यूनिटी मीन्स find out the admittance in the demand part equal to 0. That will give the XC. From that you get a C value. You get a option is this. A आते हैं 2.18 12.05. So now closing the session, almost we discussed the 21 problems. We discussed the based on basics, transient and steady state response, theorems, two-port network, magnetic coupled circuit and steady state AC analysis. So all the best. Only 2 weeks time is there. I already provided some short notes, so please go through the short notes whenever revise purpose. All the formulas रेजोनेंस में फार्मूलास रहते, रिमेनिंग चैप्टर्स में तो फार्मूलास तो नहीं रहते हैं. सो फार्मूलास तो याद रखो. So almost all the types of problems are covered here. So all the best. Thank you.